are going to learn about the instructions by an example. Use this PIP-8 virtual computer. So that it is an abstraction of the real computer. So it's not a real computer, it's a virtual computer, but it contains all the required functionalities of a real computer. They are same. So we use such kind of hypothetical machine. Okay, it's a hypothetical machine to learn about these instructions and the machine language, which is designed to contain all these important features. Okay, so all the important features has been contained, and we want to illustrate all these such kind of important features. So a PIP-8 virtual machine, it is a virtual computer which is designed by the Stanley Wofford, and it has 39 machine language instructions. Okay, so all the computer functionality was accomplished by all through these 39 machine language instructions. Okay, you just use simple instructions, 39 simple instructions, and then we accomplish all these complicated tasks. And we are not going to cover all of them. We just show several of them as the most important contents of them to learn about the important parts. So recall, we have said in our last class that any control unit, the ALU and control unit in this CPU, it has a lot of registers, right? So a register is a small area of the storage. Okay, so firstly it's a storage, and the area is very small. As I said, it's like a school bag you carry every day in your classroom instead of the whole library for the storage of your books. So it's a small area of the storage, and it is in the ALU of the CPU that holds some very special data and immediate values. So for the instruction and also the fetch, decode, and execute cycle, one of the important things is that we have several important registers which contain very special data or instructions. So we learned 3 of them here. Okay, 3 registers, very important registers here. The first we call it a program counter, as a PC in short. So in this program counter register, it contains the address of the next instruction to be executed. So we have said each instruction was stored in the computer's memory. So it has a related address for the memory, right? We said each position has its address. So if we need to know, the instructions are stored in the memory, where of course it has address. So we need to know what's the next instruction we need to perform. So we need to store the address of the next instruction in the computer. So that is what the program counter to do, the task to do. So the program counter contains the address of the next instruction to be executed. So the computer can be executed or play all the programs or the instructions in a very sequence way, one step by one step for the next instruction, right? It fetch such kind of instruction, it decode it, it fetch it, it decode it, execute it, obtain some data from the memory, and then it executed it, and then it check the program counter so that it can obtain the next address, the address of the next instruction, and then also the cycle like fetch, decode, and find the data and then execute such kind of cycle. So obviously it's a very important instruction register. And then the second important one we'd like to introduce is we call it instruction register. We say it as IR in short. So the instruction register contains a copy of instructions being executed. So it is the copy of instruction being executed. Okay, so this is what we are executing the instruction. Okay, So, and then the third one is we say it's an accumulator, okay? We also call it an A register in short. So it do the accumulation as its name, accumulator, okay? So in this PIP8 machine, it had a memory, and the memory suite is made up of 65,000 bytes of the storage. So remember, what does this represents? 2 with the power of what? How many 2 with the power of what? Supposed to be this number? In this machine, how many bits do we have? How many bits? It's supposed to be 16, okay? 16. So this machine is a 16 bits machine, okay? So it represents from, for example, in the memory, it is from the 1111 to FFFF. Oh, okay, in the hexadecimal, in the memory, okay. Okay, so then let's check. They have said you can check in this machine how many bits we use to represent the data in each register. For the A register, which is the accumulator, which is used to hold data in the results of the operation, which is a spatial storage register referred in the ALU. So we can check how many bits is supposed to be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 16 bits, right? We use 16 bits because here, okay, we use 16 bits to represent each instruction or each data, okay? And like the program counter is similar, okay, it has 16 bits. But in the instruction register, which is, remember, store the instruction now being executed, we use 8 bits plus 16 bits to represent it. Okay, so that is 24 bits. 24 bits to represent each instructions. Okay. So this is its memory. We have said from the because it's also 16 bits. So if we use hexadecimal, it's supposed to be 4 hexadecimal digits. So the memory address is supposed to be 00 to FFF.